Welcome once again to another options video. This one is going to cover the second characteristic of a viable option pricing model. And this has to do with the lower bound for the value of both calls and puts. So it ends up that the lower bound for both calls and puts is their intrinsic value. Okay, and of course now we're talking about American options. Okay, so this is for American options. American options can be exercised prior to the expiration date, as opposed to European options, which can only be exercised on the expiration date. So we're talking about American options. Okay, and so intrinsic value is the lower bound, and so I'll remind you that for a call option, intrinsic value is equal to the maximum of stock price minus strike price, or 0, multiplied by 100. For a put option, intrinsic value is equal to the maximum of exercise price minus the stock price, or 0, times 100. So intrinsic value is the lower bound. Okay, so that's the rule. The lower bound for both calls and puts for a viable option pricing model is intrinsic value. Well, let's now look at a violation of that. Okay, so we'll look at calls first. So we have a call, has an exercise price of 45. And its price right now on the market on a per share basis is $3.30. Okay, $3.30 per share, or $330 for the contract. The stock price at the current time is assumed to be, let's say, $48.50. Okay, stock price is $48.50, and this is not a price that is consistent with an equilibrium, because the intrinsic value of the call, check it out, the intrinsic value of this call is the maximum of S minus X, or 0, times 100. Stock price is $48.50. Exercise price is $45. That's bigger than 0, and that's 3.5 times 100. So $3.50 times 100 for the contract value. The per share value is $3.50. And that's intrinsic value, which is the minimum value the call can ever possess as an American call. But we stated that by assumption, the price is $3.30. Okay, so this violates the condition, and there it is. There's an example of a call price given a certain price for the stock violating the lower bound condition of intrinsic value. So what do we do? What would you do if you saw this? If you saw, these prices simultaneously, what would you do? Well, it's actually quite easy. What you would do is you would say, call's underpriced, so I am going to buy the call. So I go long one call with an exercise price of 45, and I do this at right now at date 0. Okay, so this is all right now. All right now at date 0. And the cash flow associated with buying that call is, for the entire contract, of course, is an outflow of $330. And the next thing I'll do is I will short sell 100 shares of stock. Okay, and the current stock price is $48.50, so I'll receive 100 times $48.50, or plus $4,850. Okay, $48.50 coming in. And then to cover that short position, I will exercise my call. And my call option gives me the right to pay $45 a share for 100 shares. And so that's an outflow of $4,500. After I do that, I don't have the call anymore because I exercised it. And received 100 shares. And since I had a short position of 100 shares, it effectively covered the short position. So what am I left with in my account? Well, you just have to add up these values here, and you can see that well, the outflows 4,500 and 330 or 4,830. The inflow here is 4,850. So I'm up $20. And well, that's how I profit. That's what I do when we have prices like these prices, stock price and call price, which are violating the lower bound. So, and here I can see I would make $20. How many times would I do this? As many as I could. But now we get at the issue of, how do good markets work? And what happens then is the arbitrageur, in this case me, my trades, what they're doing is pushing prices back toward a pair of prices that together do not allow for an arbitrage like this. I'm buying the call, I'm bidding up its price, I'm selling the stock, I'm driving down its price. So what's happening here is the price of the stock is getting bid down, the price of the call is getting bid up. And at some point, I can no longer make end up with a net credit when I open this position. Okay, at some point, there's an infinite number of points like that, I guess, or certainly a large number of them. 330 can go to 350, and 4850 can go to 4820. And in that case, for example, this would be a negative number, for example, and it wouldn't work. So the way good markets work is they are such that as arbitrageurs make the trades that they make in an attempt to capture the arbitrage profit, that eventually they drive prices into an equilibrium relationship. And that's how good markets work. Okay, let's look at this now from the perspective of the put. A put. So now we'll look at a put. Remember, the idea is the lower bound for a put option in a viable option pricing model is intrinsic value. And let's look for an example where that intrinsic value minimum is violated. Let's assume we have another stock that's currently priced at $64 a share, and there's a put with an exercise price of let's say $66. It has an expiration date sometime in the near future. We'll say I don't need to specify that now. And let's say that put has a price of $1.50 on a per share basis, so $150 for the contract. Okay, so what can we do? What can we do if we run into a circumstance where we see, these prices simultaneously? What can we do? Well, let's think. Intrinsic value for the put is the maximum of x minus s, or 0, times 100. X minus s would be 66 minus 64. That's 2. 2 times 100. 2 is bigger than 0, so $200. Or $2 on a per share basis. Right here, it's only $1.50 on a per share basis. It's underpriced. Oh, interesting. So in this case, we see the put price given the stock price of 64. The 66 strike put is underpriced. Well, what will we do? Well, how would we arbitrage this? Well, here, what we'll do is this is at date 0 now. We will buy the put with an exercise price of 66. And the cash flow associated with doing that is I'm out $150. Okay. The second thing that I will do is let me just help you think through this. When I buy the put, I have a right to sell 100 shares at the price of 66. But I don't have the shares. So what I'm going to do is I am going to go out right now and buy 100 shares at a price, at the current market price, of 64. So therefore I'm going to spend $6,400. Okay, so buy 100 shares, sorry. So buy plus 100 shares, buy 100 shares at $64 each, and therefore spend $6,400. And then now I own the shares and the put. Last thing I do at date 0, exercise my put. Well, this put gives me the right to sell 100 shares at 66. I happen to have 100 shares. If I didn't have 100 shares, I'd end up with a short position, but I happen to have 100 shares, so I'm going to sell them for $66 each. 66 times 100, I have $6,600 coming in. Let me see, I exercised my put. It doesn't exist. It gave me the right to sell 100 shares, therefore these 100 shares are gone, and so I don't have anything in my account except what? Well, here's my outflows are $65.50, my inflows $6,600. In this case, I have $50 extra. So I just made $50 for every put I buy and every 100 shares I buy at the same time. Interesting. So there's my profit. Can this last forever? No, of course not. How many times am I going to try to do this? Well, as many as I can. But what's happening is, well, as I buy the put, as I'm buying the put, I'm obviously driving up the price of the put. So the P represents the price of the put. So the price of the put is rising. And as I buy the stock, the price of the stock is also rising. I'm driving up their prices. So I'll go up here and say I'm driving up the price of the put, I'm driving up the price of the stock. Well, as those two prices get higher, there's a whole lot of different combinations of those two prices that would not result in a positive number there. Okay, and it's easy to see because I'm buying the put, I'm buying the stock. So as both of these prices get bigger, right? Right now, my outflows here are only $50 less than my inflow, but as these numbers get bigger, eventually the outflows are going to exceed the inflows. And there are, again, an awful lot of combinations of put prices and stock prices that we might end up at, but we're not going to end up in equilibrium such that we have a positive value here. This is an arbitrage, and we exploit them when we see them, but good markets are such that arbitrage opportunities don't last forever. Eventually, an equilibrium pair of prices will come into existence. Again, arbitrageurs, like to make the profit they're making on their arbitrage trade. Markets are markets, and good markets are such that when these arbitrageurs execute their trades to capture arbitrage profits, that those trades themselves actually work to push prices back to equilibrium. And there we've seen in this video that if we're building an option pricing model, the second characteristic is the lower bound for the prices of puts and calls, and this video has helped make clear that that lower bound for both puts and calls is intrinsic value. Thanks for watching.